Hello students, welcome to today's session. So is this particular video is in regard to the series which we have started for the doubt discussion sessions. So this in today's session there are two doubts which is being asked by a girl from the south, and let us discuss today's doubt, and what is being asked in these two doubts is the this particular question. So in this question, chromium pentoxide is being treated with sulfuric acid, and basically you need to do it with the balancing. A simple question where a simple mole concept has to be applied. So matter of the fact here would be that how to do the balancing of this particular equation. This is seems to be an easy question, but if you go into the depth of this particular question, you would find a good amount of knowledge about this particular compound. Now, if I do simply by hit and trial method, the things are quite easy. Basically, hit and trial method would be applied rightly when you are being provided with all the reactants and products formed and used in the reaction. Now, in this particular case, they are asking if you are being given 1 mole of chromium pentoxide, how many moles of oxygen is being produced? This is what the question is. Now we can simply do it this way, that then I will discuss it in detail also, that you could see that there are two chromium on this side, so I first balance the chromium and then you can balance the sulfate ions. So I am first endorsing the point that chromium sulfate I somehow happen to do the balancing. So I placed it here, so 3 sulfate is being generated, and thereafter you could also see that the hydrogen here has become 6. So this hydrogen is also became 6. Now the only thing which we are left with is 10 oxygen. These are 10 oxygen atoms here, and on this side here you have 3 oxygen atoms, and here you have O2. So what I can do is that there are 10 oxygen on the reactant side. If I am able to do 10 oxygen on the product side, I am through the question. So if I do multiply it by 7 by 2, this 2 and 2 got cancelled. So 7 plus 3 becomes 10 oxygen. So here what I shall be doing is 7 by 2. So what we are able to see here, that 2 moles of chromium pentoxide, because the reaction has got balanced, 2 moles of chromium pentoxide produces 7 by 2 moles of oxygen in this reaction. Had I took had I took 1 mole of chromium pentoxide, the answer to this would be 7 by 2 by 1 by 2 moles of oxygen, that is 7 by 4. So the answer is very clear. The fourth option would be the answer. Now, once I go into the depth of it, it would become very interesting, because this is the query being generated, which method is to be used for the balancing if we consider it as to be redox one. So if you consider it from the redox point of view, it is very interesting. For that, first you have to understand the structure of chromium pentoxide. Chromium pentoxide has a butterfly structure. This also in another way is a very good question. Butterfly structure from the chemical bonding aspect point of view. So chromium pentoxide, this is oxygen, oxygen. So basically, if you consider the oxidation state, so these two electrons and these two electron, oxygen being more electronegative, so we shall be saying here the oxygen is -2 and this chromium is +2. From this bond, if I consider from this bond, it is +1, this is -1. And these two electrons are between the oxygen. So here from here side, the oxygen is having 0 oxidation state. And this is +1, -1. And similarly, if I take consider these two electrons also on this side, if I say it on this side, this is +1, this is -1, this is +1, -1, and this is 0, 0. So there are 4 oxygen which is in -1 oxidation state. So ideally we need to write it like this. This is the exact way of writing this particular compound. So what we did is this is -1 and this is -2. So there are basically this moiety which we have drawn it like this is a peroxy linkage. This basically is a peroxy linkage where the oxygen is carrying -1 oxidation state. So now let us go into the depth of it. If you happen to go by conventional way of doing balancing, it won't be applied in this particular case, because there are lot many reactions which you can see in the playlist of n factor series, where I have done many of these type of offbeat questions. Now what is to be done in this case? So chromium sulfate along with water along with oxygen. Now we already have done the balancing. If I just show you the balancing, that this was 2 and this was 3, this was 3 and this was 7 by 2. Now if you do the tabulation in the terms of the electron exchange, this is very interesting to explain it here. That could also be a very interesting question, that how many electrons is being exchanged within this reaction, that how many electrons, who has lost the electrons and who has gained the electron, then this question would have become very tough. Now the point is, what is to be done in this case? So this chromium is in +6 oxidation state, there are 2, and there are 8 oxygen, because here we have already did the balancing by hit and trial, and now we are checking it out, that how to balance, how to do the electron exchange, or how the transaction of electron has happened. That in a way is a very interesting viewpoint here. 8 oxygen is of -1 and 1 oxygen is of, or 2 oxygen is of -2. Now here what you are seeing is, this is chromium +6 -1 -2. Who is undergoing change in oxidation state? This chromium goes to +3, and sulfate, all the entities related to sulfate remains as such. So there are 3 sulfate on this side, there are 3 sulfate. So there is no oxidation change in the case of sulfate, as well as in the case of hydrogen also. The hydrogen 6 hydrogen is in +1 oxidation state. Here you have -2 and 0. So basically, if I show it like this, there are 2 chromiums of +3, and there are 3 oxygens of -2 and 7 oxygens of 0 oxidation state. This 7 oxygen is of 0 oxidation state, these 3 oxygen is of -2. Now how to do the calculation part? Now you could see that if I do that, chromium 6 goes to chromium 3 positive, this would go by taking 6 electrons. 6 electrons, because one chromium 6 positive when goes to chromium 3 positive happens to take 3 electrons. So there are 2 moles or 2 chromium atoms, so it shall be taking 6 electrons. This is clear to you. Now what is the contribution, or how the electron exchange has happened within the oxygen? That is very interesting. So there are 8 oxygen of -1, 2 oxygens of -2, which happen to go to 3 oxygens of -2, and 7 oxygens of 0. This is not 70, this is 7 oxygen. How do I write it? 7 oxygens. Okay, now see here what I shall be doing now. So if I would do it like this, I just further divide it like this: 7 oxygen of -1 and 1 oxygen of -1. So this 7, this is beautiful. This 7 oxygens of -1 goes to 0. If it goes to 0, what has happened? What it did? It has lost 7 electrons, because oxygen, if I write it separately here, if I show it to you, 7 oxygen of -1 goes to 7 oxygen of 0, that means they have lost 7 electrons. Then only the charge balancing is there along with the atomic atom balancing. So now the point here is that somebody has lost 7 electrons. Now some species have to gain that 7 electrons. 6 is already being gained by chromium 6 positive. Now here comes the interesting part. These two oxygen have not changed their oxidation state. They went to 3 oxygen O2 as such. But this oxygen, when going to this side, has also gained 1 electron. So in totality, what is being done by what? Now this is very interesting. Did you get this point? Let me show it once again for your understanding. So the point here is, we had 2 chromium of 6 positive, 8 oxygens of -1 and 2 oxygens of -2. And if I break up it like this, that these two, this proxy linkage, oxygens are doing a trick here. 7 oxygen -1, 1 oxygen -1. So where it went to chromium 3 positive, 3 oxygen -2 and 7 oxygen -2, 7 oxygen 0. So now see here what we did. So this have taken 6 electrons, this also have taken 1 electron, beautiful. So who has lost who has gained 7 electrons? One atom of oxygen as proxy oxygen and two chromium atoms. And who has lost these electrons? Beautiful. So these 7 electrons are being lost by this. 7 electrons are lost by this. Now if I happen to go for the per mole, let me add one page here. So if I add one more species here, if I divide entire of this, basically out of the two, now this is very interesting. It is going very interesting. So what basically we are able to see here, chromium pentoxide treated with what? Sulfuric acid, and we took it as 2 and this was 3, went to chromium sulfate with 3 water and 7 by 2 oxygen. Now if I divide entire of this equation by half so that it becomes per mole, so this becomes 3 by 2 sulfuric acid, this would become 1 by 2 chromium sulfate, and this becomes 3 by 2 water and 7 by 4 oxygen. This is what we did. So now this has become per mole. So per mole, how many electrons are being exchanged within it? So here in 2 moles, how many electrons are being exchanged? Within 2 moles of this compound, let me show it. Where should I show it? So within, let me show it here. So this 7 electrons, these 7 electrons are exchanged within 2 moles of chromium pentoxide. And if I would want that how many electrons are being exchanged between 1 mole of chromium pentoxide, it would be 7 by 2. So we shall be saying that in this case, uh, per mole per mole 7 by 2 electrons are being exchanged, and that could be said as the n factor of chromium pentoxide in this particular case. N factor of chromium pentoxide in this case would be number of electron exchange within the molecule and taken by number of moles. So N factor of chromium pentoxide in this case would be 7 by 2. This is very interesting. So if in case somebody asks the if a examiner happen to make the things little tricky in the sense that they start asking you that who has underwent oxidation and who has underwent reduction, that is very interesting. So we shall be saying that the thing here is that the proxy atom, out of the 8 proxy atoms, 7 has underwent oxidation and 1 underwent reduction. Or for that matter, if I convert this for per mole, out of the 4 oxygen atoms, 7 out of the 4 oxygen minus 1, 3.5 underwent oxidation and 0.5 mole underwent reduction. That is very interesting to tell here. Now the second question which the girl has asked is something related to organic chemistry. So here the girl has asked this particular question that you need to understand, you need to evaluate which is the false statement in this particular problem. So I could see that this carbon is chiral in the sense that there is 4 different groups attached here, and for this particular species this also is chiral, because this is what you call it as there are if I draw it like this, you can figure it out better, that this is the compound, this is Cn, and this is CH2 CH3 OH. So you need to first evaluate the stereocenters. So it is easy to explain it here that this is stereocenter because it can show dextro and levo, and this here it is, if I show it like this CH3, so now you could see this is chirality. This is also having a chiral carbon. So this can also show dextro and levo, so D and L. And along with it, what you are able to see, if I happen to see that this double bond, a geometrical isomerism is possible when doubly bonded carbon atoms are attached with non-identical set of atoms or group of atoms. So this is different from this one. isn't it? And this CH2 and this CH2, although identical, but the second point of difference here, it becomes non-identical. So this part I would say is totally different than this part. So that means it can show geometrical isomerism. So wherever a double bond is able to show a geometrical isomerism, that double bond in totality could generate E or Z or cis or trans type of a thing. So that double bond in itself would be said as a stereocenter. This would be said as a stereocenter. So how many stereocenters do we get? So we shall be getting a stereocenters like this. We have this as stereocenter because it gives D and L. This double bond can give you E and Z. This stereocenter could also give you D and L. So in totality, you have three stereocenters. So first option is incorrect, which is what is being asked. Now the configuration at the double bond is E or Z. E is somewhat like E is an alphabet like this, where the groups are on the same side, but it would be said as a trans type of a species. In a sense that, why I'm saying it this way, because when you start numbering it from the um, priority series, so this is 1, this is 2, and on this side, this is 1, this is 2. Because at the first point of difference, this would have more heavier, it would have a carbon atom more. So 1 1 got opposite and 2 2 got opposite. That is what you call it as E. Tip to remember. And Z word in itself shows, when you write somewhere Z, it seems like opposite, but it is cis type of a species. So it is E. Definitely it is E. What else it has been asked? So this is correct. Will it be showing optical isomerism? Yes. Will it be showing geometrical? So it is, I think it is clear to the girl who has asked this particular question. The main query she has asked is that how to identify that when whether a double bond is a stereocenter or not. When a double bond starts showing any geometrical isomerism, it can be considered as to be a stereocenter. Thanks a lot. Have a nice day. And do keep sending me your doubts. As and when I get time, I would be making video solution on daily basis. Thanks a lot. Have a nice day. Stay safe.